All right, so let us explore in detail and have a look more specifically the architecture of Arduino, which is ATmega, ATmega 328p microcontroller. Remember, it is 8-bit microcontroller. It is a RISC type of architecture that stands for Reduced Instruction Set Computer Architecture. And the name of the chip, right, this chip is ATmega 328p. It's an 8-bit microcontroller that will operate on 8-bit data at a time. So when the microcontroller performs some operation, which is indicated by a specific instruction such as add, subtract, or perform some digital logic operation, ANDing, XORing. So it has to fetch some data from, let's say, memory, or it has to store some data back into the memory. It will always be an 8-bit at a time. That's why it is called as 8-bit microcontroller. Now it's CPU. That's the CPU. Remember, inside this chip, we have this kind of architecture. This kind of architecture, we have covered that in the previous model. So it has inside the chip, you have CPU, you have interrupt control section, you have memories, RAM, ROM, you have input-output ports, and there are unidirectional or bidirectional address and data bus, all operating at 8-bit. So we come back to our slide. So its CPU, it uses a single cycle for its operation to perform instructions and data. Based on the instructions, it performs some operation on a data, and it has 131 powerful instructions. So you see, that's why we also call it as a RISC type of architecture. Reduced instruction, only 131 powerful instruction to perform arithmetic, logic, and control operations. And it has 32-bit small memory units called as registers. I told you registers are used to hold a temporary storage of data when the microcontroller will do some operation. And each register has a capacity of 8 bits. So 32 multiplied by 8. Remember, 32 registers, each register has a capacity to manipulate 8-bit data at a time. So they are called general purpose registers. And special registers are also a feature of Arduino. They are used, they are called as status register, control registers, and IO registers. Finally, inside the chip only, we have 3 kinds of memories. That is a strong feature of Arduino Uno. What is that? It has 32 kilobytes of flash to store the program that we will write. It has 2 kilobytes of static random access memory, SRAM, to store the data. When we'll do some operation, it will generate some data, and to store that data, it will use this capacity of SRAM. And then it has 1 kilobyte of EEPROM. We have told you what is EEPROM. For non-volatile data storage. It means non-volatile means even when you do some operation and the light is switched off, the power is switched off, the data will remain stored in this memory of 1 kilobyte, so that when the power resumes, your data is not lost and you can reuse and re-perform the operation. Okay, so that's the feature of architecture of Arduino.